For many decades, physicists have theorized that the universe is filled with an exotic material called dark matter. Its origins and composition remain among the most elusive mysteries in the modern cosmology.
When we're thinking about this puzzle, that there's motion in the universe that seems that we can't explain it using the stuff that we can see using light, there seem to be two general ways of addressing this problem. It could be that there's more stuff out there than meets the eye. There could be dark stuff. But it could also be that our understanding of the forces, and in particular the force of gravity, needs sort of a deeper explanation. And when we're talking about dark stuff, the natural thought that might come to mind, it's the kind of stuff that we know about. Maybe it's planets, maybe it's stars that have burned out, maybe it's black holes that are out there in the universe. That's sort of one collection of possibilities. The other collection is fundamental ingredients that make up those entities. Particles, perhaps the ones we know about, or perhaps hypothetical particles.
Dark matter is material that cannot be seen directly. It is composed of particles that do not absorb, reflect, or emit light, so they cannot be detected by observing electromagnetic radiation. If dark matter cannot be seen, how do we know that it exists? Scientists study dark matter by looking at the effects it has on visible objects. They believe that dark matter may account for the unexplained motions of stars within galaxies.
A related idea that has a deep connection to theories of gravity, our understanding of the force of gravity, the possibility that many scientists have bought into over the course of many decades, that there's much more to the universe out there that meets the eye. And the reason that we've come to this conclusion is by virtue of studying the gravitational pulls that happen out there in the cosmos and coming to the conclusion that the stuff that we see is unable to give rise to the gravitational pull that we observe. And one way of thinking about this is to imagine that, you're flying into New York City at night. And as you fly in at night, of course, all that you really can see are the lights in the buildings. Now, we all know when we see an image like this that there is more structure to the image, to the reality, than the lights themselves. How do we know that? Well, because we all have an intuitive understanding of gravity. And if there were no buildings, if there were no structure out there, these lights, they'd fall down to the ground. And because they don't fall, we know that there is something out there that's holding them up. And of course, by the light of day, we can begin to see what that structure actually is. And of course, we all know what the structure is. It is the architecture, the physical makeup of the buildings themselves. But without being able to see that structure itself, if we only have access to the light, which is all that we have access to when we look out to the universe, we have to infer the existence of the dark stuff that's not visible at the moment. And that's how we come to this conclusion that when we're talking about not a cityscape, but the universe, that there might be more out there than meets the eye.
Scientists believe that in the first minutes after the Big Bang, this stuff was just ordinary matter. Dark matter's existence was first inferred by Swiss-American astronomer Fritz Zwicky, who in 1933 discovered that the mass of all the stars in the Coma cluster of galaxies provided only about 1% of the mass needed to keep the galaxies from escaping the cluster's gravitational pull.
So this idea of dark matter goes all the way back to the late 1800s, early 1900s. And as people began to think about this idea over the ensuing decades, and one scientist in particular, Fritz Zwicky, who was a Swiss-American astronomer, kind of a wonderful character, but he began to study the motion of galaxies in the Coma cluster. This is a few hundred light years away. And again, he found that the motion of the galaxies was such that it couldn't be solely due to the ingredients that he could see by virtue of their light. He concluded that there had to be additional dark stuff that was out there that would be responsible for the gravity that was pushing and pulling these galaxies around. But it was really the work of Vera Rubin who really cinched the case in the minds of many physicists, many astronomers, for the existence of dark stuff that's out there. Because what she did was she studied the motion of stars in swirling galaxies and found that the galaxies were swirling too quickly. The stars should be sort of ejected outward. One way of thinking about this, if you have, for instance, simple pedestrian situation where you have a wheel, right? And you have water on the wheel. If you take this wheel and it's spinning slowly enough, very little water will fly off. But of course, you give it a real spin and the water droplets fly right off. The idea was that the galaxies were spinning as fast as I was spinning the wheel so that the stars should be flying off as the water did. But Vera Rubin found that the stars are not flying off. And therefore, there had to be something else that was pulling them in, something else that's dark because we don't see it, giving rise to the gravitational pull that was holding the galaxies together. And of course, it wasn't just pictures. There's mathematical analysis behind this. The expectation was that the farther out you go from the center of the galaxy, the slower the stars should be moving. But in fact, her observations and analysis showed that that wasn't seeming the case. The speed of the stars out on the edge of the galaxy was too fast relative to what we thought it should be. They should be flying off, but they weren't. And therefore, this notion that there should be some dark stuff that would be out there.
The precise nature of these particles is not currently known, and they are not predicted by the standard model of particle physics. But there are many theories about what exactly dark matter may be. Some suggest it may be normal objects, such as cold gases, dark galaxies, or black holes. Recent results in the study of primordial black holes suggest a new perspective. According to this idea, primordial black holes that were created in the first instance after the Big Bang, tiny ones smaller than the head of a pin, and supermassive ones covering billions of miles, may account for all the dark matter in the universe. At early epochs, these black holes clustered and seeded the formation of early galaxies, and then eventually grew by feeding off gas and merging with other black holes to create the supermassive ones seen at the center of galaxies, like our own Milky Way today. For nearly a century, evidence has mounted that the gravitational pull necessary to keep clusters of galaxies intact, as well as stars within galaxies from flying apart, requires far more matter than we can see.
If you calculate the amount of dark matter that must be out there to hold these galaxies together, you find that it's 4 or 5 times as much as the amount of matter, the protons, neutrons, electrons, that makes us up. So you're talking the majority of the matter in the universe might be dark stuff, and indeed a different kind, but perhaps related, dark entity called dark energy. Bottom line is, the stuff that makes up you, me, and everybody else may be a tiny sliver of the mass energy budget of the entire universe. We know a lot about reality, but it might be that a lot of our focus has been on a tiny piece of the full story.
This problem has proved more challenging than anyone expected, which raises the big question. What if we have failed to find dark matter because there isn't really any out there? This outlandish perspective would ultimately require rethinking some of our most fundamental ideas about the universe. Scientists are still busy understanding gravity in a more fundamental way, trying to combine general relativity with quantum mechanics, but this has developed into a new framework that could explain where gravity comes from. Proponents of this idea believe that this will help them explain the extra gravity phenomenon without the need for dark matter. Erik Verlinde is a theoretical physicist and string theorist at the Institute for Theoretical Physics at the University of Amsterdam. He argues that gravity is not one of the 4 fundamental forces of physics, but rather gravity is emergent from other fundamental forces. Many physicists have called Verlinde's arguments hard to follow. They reject the idea that classical dynamics itself needs to be modified and attempt instead to explain the law's success by reference to the behavior of dark matter. Given the considerable indirect evidence and near consensus among physicists that dark matter exists, it still probably does. However, proponents of the dark matter hypothesis have some explaining of their own to do when it comes to recent findings about the universal relationship between galaxy rotation speeds and their visible matter content. More on that on another video. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.